Hey, Mrs. Baxley, what's the matter?
I have all of these things I need to grade, and I'm just already so behind.
Oh, Mrs. B, I didn't say what's the matter, I said what is matter.
Oh, okay. What is matter?
What is matter?
Okay.
So, Miss Osmond, let's talk about matter and energy.
Okay.
All right.
All right. Matter. What's matter? What's matter made up of? What's the definition for matter?
Okay, matter is stuff. That's a Mrs. Baxley definition, as I say sometimes. Matter is exactly made up of something. It has to be made up of some kind of particles.
Sounds good.
So if something doesn't have particles, it's not matter.
Okay.
So, for instance, light.
Light.
Is it matter?
No.
Okay. How about our hands?
Matter.
Okay.
Okay. The first thing we do is we say matter has mass
Okay.
and takes up space,
Oh, very good.
or has a volume associated with it. So when you did your hands,
Right.
this has mass.
Okay.
Your hands have mass, and they take up space.
Very good.
Okay.
Very
So mass is the amount of matter, and volume is the amount of space.
Excellent.
Okay.
Very good. So, for instance, light takes up space. It's filling this room, but it
Yes.
doesn't have any mass.
But it doesn't have any
which makes
mass.
it not matter.
Correct.
Gotcha.
Okay. Now there's two different ways we can measure the amount of matter.
Okay.
Okay.
So, like, for instance, you're talking about mass, or if we took that mass and put it in different places with different gravity, we could also measure it using weight.
Correct.
Okay. But in this class, typically we're going to be using
Mass.
Okay.
We always mass, and we have a tendency to say go weigh something. We're not really weighing it. We're massing it.
Okay, very good.
So our balances are mass balances. They take a mass. Now the bathroom scale at home, that takes a weight.
So if I took my bathroom scale to the moon and stood on it, the weight would show differently because the moon is pulling me down with a different amount of gravity.
Right.
But if I were to measure the mass of something using a balance, I would get the same mass on the moon as I would get on the Earth.
Correct.
Okay, very good.
So if you weighed 100 pounds on Earth, you may only weigh 16 pounds on the moon.
Okay, but if we get to Jupiter, which is very large, so it has a very high amount of gravity.
You're going to weigh like 500 pounds, and you'll be like squished.
Oh, ouch.
Because the gravity is so big on Jupiter, it would just squish you.
Next.
Okay, some vocab words.
Okay,
Volume, the amount of space something takes up.
good.
Okay, what ways can we measure volume?
Cubic centimeters.
Cubic
That
centimeters?
would be like something, so we could measure it by measuring the length, width, and side.
Yes.
If it's not all nice, even measurements to use a mathematical formula, there has to be another way to measure volume, right?
Correct.
Okay, and what would be a good way?
A good way is water displacement.
All
We
right.
take a graduated cylinder,
Mhm.
we fill it to a certain level,
Mhm.
we record that to the right number of significant figures,
Excellent.
we put our object in the graduated cylinder, and the water rises because we've placed something else in the cylinder. We take that final measurement to the right number of significant figures, and then we subtract the ending from subtract the beginning from the ending reading,
Okay.
and that difference is our volume in milliliters, which 1 milliliter also equals 1 cubic centimeter.
So milliliters we typically use for liquids.
Correct.
Cubic centimeter would be more for solids.
Yes. Next vocab word is atoms.
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 Atomos,
Atomos.
from the ancient Greeks.
Yes, we'll learn about that next unit.
Okay.
But in the meantime, we're just going to think of an atom as the smallest building block of mass, of an element.
The smallest building block. So if you get any smaller, it wouldn't be the same thing
Right.
anymore.
Like an atom of helium is the smallest building block of helium. But if you take that atom of helium and break it into its component parts, the subatomic parts, which are protons, electrons, and neutrons, it would no longer be a helium atom.
Okay, so we could compare maybe different atoms to different kinds of vehicles. For instance, if
Yes.
you've got a unicycle,
Mm-hmm.
has one wheel.
Right?
You have a that could be like a hydrogen atom that has one electron. You've got a motorcycle,
Yep.
2 wheels. You've got a 3-wheeler. You've got a car.
Mm-hmm.
You have an 18-wheeler.
Yes.
They're all vehicles.
Right.
but they're all different types of vehicles because they have different numbers of wheels. Wheels are some of the parts that make it up.
So if you remove the wheels from each one of those,
Mhm.
they would no longer be
Of functional
a
vehicles.
functional vehicle. So
It would just be parts of
just
vehicles.
parts. So it's kind of like you've broken the atom down, you've broken the car down.
Okay,
All right.
excellent.
And the last thing are molecules, and that's where we take atoms that are held together by chemical bonds. Of course, the most famous example being water or H2O.
H2O, so that would be like we have one, or let's say we have two Honda motorcycles,
Okay,
and they crash into an Odyssey minivan.
there you go. H2O.
All right.
All right, awesome.